All right, so this is the last of our lessons here on cohesion, adhesion, and surface tension. I want to give you a scenario. Let's say you were baking or doing something and you get butter or oil all over your hands. It's gross, it's slippery and gross, and you want to get that off of your hands. What are you going to do? How are you going to get it off your hands? Are you going to just put your hand in the sink and wash it off with water? Will that work? Well, why not? Why doesn't it just wash off your hands? Water is not going to get the grease off your hands because oil or grease is nonpolar and water is polar, and those intermolecular forces are too weak to be able to have the water stick onto it and remove it. The water molecules are just going to slide right off and down the sink, and your hands are going to be as greasy as they were before. So you're going to use soap. So the question is, what is soap, and why does soap get the oil off your hands and wash down the drain? Well, we have to get to what is soap anyways. So soap is made, and this soap goes back thousands of years. People figured out soap, and basically it's made with a combination of animal fat, aka lard, which is rendered animal fat, and or vegetable oil, depending on the texture and whether you want it to be a bar of soap or a liquid soap. And then using caustic sodium hydroxide or potassium hydroxide pellets in something called lye water. And so people realized way back when that if they took animal fat and mixed it with the ashes from campfires, it was great at getting grease off their bodies. And so the first soaps were invented through that basic process because, as it turned out, the ashes out of the fire actually had quite a bit of this sodium hydroxide in it. People didn't know why it worked, but of course, they did it. Nowadays, there's kind of a cottage industry out there of people making their own soaps at home, and it's actually kind of a dangerous process. What you need to do is boil this caustic sodium hydroxide in with lard, and you get this bubbling, boiling mix that can be very dangerous. If that sodium hydroxide gets in your eyes, it can eat away at your eye tissue and cause you to go blind. That's why they're wearing the protective goggles. But the general process is pretty simple to make soap. You mix these two together at boiling temperatures, and then it'll eventually, as it cools, solidify into a bar of soap. Okay, so how does soap do it? Well, when you mix that fat or oil with those sodium or potassium hydroxide molecules, you create a long linear molecule that contains two parts to it. You have a polar head, which we call the hydrophilic head because it means to like water. Phil means to like, so hydrophilic means to like water. And you've got a hydrophobic tail, or a non-polar tail, which is made up of those fat molecules. That means that these two parts of the molecules can interact with different kinds of other molecules. So first, when you have that oil on your hand, you put the soap on it, and the oil molecules will begin to attach to the nonpolar tail. We say like dissolves like. Oil is nonpolar, it's going to be attracted to other nonpolar substances, while water is polar and will be attracted to that polar head. So as you wipe the soap onto that oil, the oil molecules begin to attach, being removed from your hand and onto the soap. Then when you put the soap under water, the water molecules start flowing past the head and start sticking on and pulling the soap molecule with it. And as the soap molecule goes in with the water, it takes the oil that had already attached itself down the drain with it. So the oils dissolve into the nonpolar tail, while the polar head is attracted to and pulled away by the running water. So what about that really tough grease? I'm sure you've worked on a bicycle, maybe a car, you've gotten that really nasty grease that soap is just not getting off. How do you get that off of your hands if soap is not good enough for it? I know you can buy that goop stuff or special stuff that's designed for really tough grease, but there's actually a really simple solution you can do right at home. Use vegetable oil first. So the first thing you do is go find some cheap vegetable oil that might be around your house and wipe that onto the oil. Because they're both nonpolar, the grease will begin dissolving into that vegetable oil, and it'll start coming off your hand. Now, it'll still be on your hand, but it'll be mixed in with the vegetable oil as opposed to attached directly to your skin. Then you want to get some soap. The soap will then begin dissolving the vegetable oil onto those nonpolar tails, and the soap will then wash down the drain. So if you get really tough stuff that just won't come off with soap alone, try some vegetable oil first, then use regular soap. And I'm telling you, it works every time. Okay, so a surfactant is a substance that disrupts and lowers the surface temperature tension of a liquid. And surfactants are really important because we use them in detergents to clean our clothing and to do other sorts of cleaning like that, whether it be your dishes or your clothes. So detergents, like soap, contain a polar and a nonpolar end. When you add them to water, they have a tendency to attach to water molecules, but they start interfering with the ability of water molecules to attach to themselves. So they lower the surface tension of the water and they break that surface tension. Then the surfactants start to interact with oil molecules or other nonpolar molecules and start lining up those tails all around it, trapping them as tiny, tiny little bubbles or droplets that can be washed away more easily. Surfactants is how bubbles form. So when you have bubbles, you've got a surfactant in which, if you look here, they create these polar heads, start surrounding water molecules on two sides, and start creating basically a shell around the water molecule. At the same time, they have nonpolar tails that prevent the water molecules from evaporating rapidly into the air. And so basically they trap those water molecules in this shell, and then there's a little bit of air in the middle that is inside of the bubble. And so the bubbles will blow around until eventually some water molecule is able to find a little hole between them and kind of escape and evaporate away, and then the bubble will pop. But once the air is able to shoot out through the tiny gap that forms when a little bit of water escapes, that's when the bubble pops. Here's an amazing picture to leave you with of surface tension, where by dropping the glass in, this huge column of air forms around it because the water is sticking to itself and not rushing in to basically fill the gap that is left behind. All right, that's your topic. See you next time.